Hey guys, this is CHEMPLIFIED and today we will talk about our new topic, redox reaction. Let's start without wasting any time. The term redox is made up of two terms. First is red and second is ox. Here red represents reduction, ox represents oxidation. Both we have taken red from reduction and ox from oxidation. So redox reaction is a reaction in which reduction or oxidation takes place, right? Now we will take a look at oxidation and reduction separately. First, let's see what is oxidation or what are the different definitions of oxidation. Now there are a few definitions that I have written. First one is addition of oxygen to a substance. When you add oxygen to a substance, it is known as oxidation. Second is removal of hydrogen from a substance. If hydrogen is being removed from a substance, from a species, then it is also known as oxidation. Third one is increase in oxidation number of a substance. Oxidation number or charge of any species, if it increases, then that means it is undergoing oxidation. And the last definition is the most general and most useful for you, that is oxidation is nothing but loss of electron. Now we will use this definition a lot of time. Why? Because if you see the first definition, it is addition of oxygen, second is removal of hydrogen. In most of the cases, in most of the reactions, you will not find oxygen and hydrogen. There are only a few reactions in which you will find oxygen and hydrogen, and on the basis of these two, you can tell whether it is oxidation or reduction. But if you look at the last definition, it is using electrons, and in every reaction you will find electrons. So this will be the most common and most useful definition. You can also remember this definition. Oxidation is loss of electron by the term oil. You all are familiar with oil. Here O stands for oxidation, I stand for is, L stand for loss. Oxidation is loss, and since we are talking about electrons, we know that oxidation is loss of electrons. So this is the short term that you can use. Now let's take an example. For example, zinc. Zinc can lose 2 electrons and can give Zn2 plus 2 electrons. Now since zinc is losing electron, it is undergoing oxidation. Here the oxidation state of zinc is 0 and here the oxidation state is plus 2. So the oxidation state is also increasing. So this definition will also work. Increase in oxidation number of a substance. So since oxidation number is increasing, oxidation state is increasing, zinc is undergoing oxidation, right? So this will be the definition for oxidation. Remember, since these are the definitions for oxidation, the definitions of reduction will be equally opposite to these 4 definitions. Let's look at reduction. Now, the definition for reductions are removal of oxygen from a substance. Removal of oxygen from a substance or addition of hydrogen to a substance is reduction. Now there are only a few reactions that will involve oxygen and hydrogen, so these two definitions will imply on that only. Now let's move to the third. Decrease in oxidation number of a substance. As the oxidation number or oxidation state decreases, which it simply means it is the substance or the species is undergoing reduction. Now the most common definition, which involves electrons, is reduction is gain of electrons. There is no need to remember this definition because you already know oil. If you know oil, you will also know reduction definition. Oxidation is loss, so simply reduction is gain of electron, because oxidation and reduction are just opposite of each other, right? So If oxidation is loss of electron, reduction is gain of electrons. Let's take the example. Copper 2 plus 2 electrons will give copper. Now the oxidation state is plus 2. Here the oxidation state is 0. Right? So the third definition will work in this place. Oxidation state is decreasing from plus 2 to 0. Now we will talk about electrons. In this case, 2 electrons are being added, right? Or copper is gaining 2 electrons. So it is undergoing reduction. You can remember all these definitions, or if you can't remember all these four definitions, just remember the last two in both the cases, oxidation as well as reduction. These two definitions will work everywhere, right? Why? Because oxidation number is also increasing or decreasing because of transfer of electrons, and the last definition is simply based on electrons. Now we will come for the definition of redox reaction. Since you know the term redox, redox is taken from reduction and oxidation, and redox reaction will simply mean reactions in which oxidation and reduction takes place simultaneously are called redox reactions. This is the simplest definition, and we will also take a simplest example. Zinc and copper, or you can go for Daniell cell. Zinc plus copper gives Zn2 plus and copper. Now if you look closely, there are two things happening. First one second, let's change the color for this one. First one and second one. Now look at zinc. The oxidation state is 0. In this case, oxidation state of zinc is 0, and it is going towards the oxidation state plus 2, which means it is losing electron. And what is losing of electron means? Oxidation. Oxidation is loss of electrons. So zinc is undergoing oxidation. Now copper, look at copper, plus 2 oxidation state to 0, which means it is gaining electron. Gain of electron means reduction. This is the most simple and most common example, copper and zinc from Daniell cell. Or when you dip a zinc rod in copper sulfate solution, then also this reaction takes place, right? Now this is redox reaction. This is one example of redox reaction. There are many more like that. This is for simple understanding that one species will undergo oxidation and the other species will undergo reduction. That's how redox reaction works. In the end, we will discuss these four terms. These are oxidation, reducing agent, reduction, oxidizing agent. These are kind of confusing, so please don't try anything else and don't get confused. Now just go for the definitions of these four terms. Oxidation, loss of electron. Now reducing agent, what is reducing agent? The definition is donor of electron. Donor of electron. Now if you look at these two terms, loss and donor, they are kind of similar. They are of similar meaning in this place. If something is losing electron, then it also means that it is donating electron, right? So oxidation and reducing agent both will represent the same species. We will talk about that. Now first go for reduction definition. What is reduction? Gain of Electron. What is oxidizing agent? Acceptor. Acceptor of electron. The species that accept electron. Now if you look again, gain and acceptor. Both these terms are of similar meaning in this place. Now we will go for the example. Our example is zinc and copper. Let's take a look at the reaction. First we will talk about zinc. Zinc is losing 2 electrons, right? Zinc is losing 2 electrons because first the oxidation state is 0 and then the oxidation state is +2. So zinc is losing 2 electrons and zinc is also donating its electron to copper, right? Copper is receiving electrons from zinc. Zinc is donating its electron. So oxidation, zinc is undergoing oxidation and zinc is also acting as reducing agent for copper. Why? Because it is donating electron. So in this place oxidation and reducing agent is zinc. Now in case of reduction and oxidizing agent, look at copper. Oxidation state of copper is +2 and it is reaching oxidation state 0, which means copper has gained electron. Gaining of electron means reduction and accepting electron. Copper is accepting electrons from zinc. Copper is accepting electrons from zinc. So it is acting as oxidizing agent. It is accepting electron from zinc. So in this case, reduction is copper is undergoing reduction and copper is also acting as oxidizing agent, right? So don't get confused. These two terms are kind of similar. These two terms are kind of similar for a particular species, right? So this will be it for today's video. Thank you very much.